Good morning, gentlemen and Kylie. Good to have you here today. We're going to be starting on Notecard 61 today, differentiability. And again, what this part of the course is a cycle back through differentiability that we already did, but we're bringing in what else in this iteration? What are we bringing in to the spiraling? Or trigonometric ratio functions, right? So here we talked about this problem, a problem similar to this earlier this week. Differentiability. Is it possible for a function to be continuous at x equals c and not differentiable at x equals a cusp, corner, or a vertical tangent? Or it is possible for a function to be continuous, but at a cusp, corner, or vertical tangent, a continuous function is not differentiable and a discontinuous function is not differentiable. So you got to be continuous, and even if continuous, you can't have that continuity in the form of a cusp, a corner, or a vertical tangent. So those are exceptions to continuity. But other than that, when you have continuity, you will have differentiability. So you got to have a smooth curve, or a line even will be differentiable. And then we have the continuity, we have the right hand and left hand derivatives are defined and equal at x equals c. And so now what we have here is a similar problem to which we worked on earlier, except this is asking about not only about continuity, but differentiability. So we actually did this, where we said the limit as x approaches, what is that critical number? 0, from the right side, or I'll say left side, from the left side of f of x is equal to limit as x approaches 0 from the right side of f of x. And so we look at this and we say, okay, well, what is that limit going to be? Where we plug in 0. So we plug in 0, what do we get here? Here. On the left side. So we plug in 0, we get 1 times 1/2. So we get 1/2 minus 1/2, or 0. And on the right side, what do we get for that? It's going to be sine x, right? So we get 0. So 0 equals 0. So do we have continuity here? Yes. So f of x is continuous at x equals 0. And then we have our next critical number, which is this one right over here. And so we have limit as x approaches 2 pi of f of x, and 2 pi from the left equals question mark limit as x approaches 2 pi from the right side of f of x. And so we just put this in here. If we put in on the left side, here's our sine x, right? If we put in 2 pi, what is the sine of 2 pi?
0.
Sine of 2 pi is 0. And on the right side, we have, if we plug in 2 pi, we get 2 pi absolute value of 2 pi minus 2 pi is going to be 0. And so we have f of x is continuous at x equals 2 pi. And so what I want you to do is I want you to go ahead and take the next logical step, and that step being to determine if you have not only continuity but differentiability here. So I want you to work on that for a couple minutes, and we'll go over that, all right? Okay. You ready to start looking at this? Okay, so now we're going to test for differentiability. So I'm going to do the same one right here. I'm going to put limit as x approaches 0 from the left side of what goes here? F prime of x equals limit as x approaches 0 from the right side of f prime of x. So let's go ahead and find these derivatives. And so what's going to be our derivative of this function here?
Something crazy.
It won't be that crazy, okay? Derivative 2 times 1/2, right?
1.
Times x plus 1. And then, let me see here, that's going to be to the first power. And that 2 canceled out that 1, that's going to be 0 here. So we're just going to have x plus 1, right? So if we plug in 0 for x plus 1, what do we get? 1, right? And then we try this one here, sine, and the sine of 0 is, or the derivative of the sine of 0 is
Cosine of 0. Which is 1.
it's going to be 1, cosine of 0 is going to be 1. So you could almost look at it as like a special trig limit, but you don't need that. So what can we conclude here?
It's differentiable.
Yeah, differentiable. Okay, since limit as x approaches 0 of f prime of x exists, this is an existence thing, right? Exists, we know what? We know that we know differentiable because of that. F of x is differentiable. Now, what did you get for the next one? Did you find differentiability for the next one? Okay, just take a minute and do that one. Okay. Now in this one, we have the limit as x approaches 2 pi from the left side of f of x of f prime of x, right, equals limit as x approaches 2 pi from the right side of f prime of x. And then what we have on the left side is this sine x here. So what's going to be our derivative of sine x? Cosine x. And what's going to be the cosine of 2 pi? 1. And the right side, we're going to take the derivative of this thing right here. Okay, what's going to be our derivative, our limit, I guess, or the first derivative of this thing here? On the right side. Okay, this one here, your limit from the right side does not exist. Why does the limit not exist? I will show you. The reason the limit does not exist is because here we have 2 pi. And so we have is the function x minus 2 pi. It looks like this. What happens right here? What is that?
Corner.
That is a corner. So that limit does not exist right here because the corner does not exist. And so therefore, and then if you look at it, let me see, that's going to be a slope. If we go just to the right of that and we plug in 2 pi, we get 0. And that's going to be, that would be a 0 anyway, where we have 1 over here. So 1, yeah, because we have 1 from the right side. That would be 1. I'm just trying to ferret that out. Because I could have been wrong about this, because okay, less than or equal to, that applies to this, and greater than, well, I think I lied to you, my friends. How did I lie to you? Because we do have a corner right here, but remember that this is going to be, we have the limit going up like this with the sine curve. So the sine curve is going up like this and has a 1, and to the right of that, that is also going to be 1. Do you see that? Because if you plug in, if you take the derivative of this, what's going to be the derivative of this? 1. And it's going to be to the right, so we have 1 equals 1. So therefore, since limit as x approaches 2 pi of f prime of x exists, and we already know that's continuous, f of x is differentiable there too. See, I was ready for that corner, all right? And then I looked at it, I said, nah, that's not quite the situation. So a little bit tricky there, okay? And now we are to this section here, 2 for the graph the piecewise function below, find the value of x, if any, where the function is not continuous. Do you see a not continuous here?
No.
No. What about a not differentiable?
Yes.
Yeah, so we would say the function, if we call this f of x, which they don't label it, so f of x is not continuous where? Or not differentiable where? It is continuous. Differentiable where? At x equals?
What do you call that? 8?
8. Because what?
There's a cusp.
Yeah, because it is a corner.
It's a corner.
Because, but here's the way you need to do it is you need to do it in calculus language. Okay, and the reason the calculus language is this, because the limit as x approaches 8 of what? Of what is our function here? F prime of x does not exist. And does not exist because this is a corner. You don't have a smooth curve going between those two.
Yeah.
Okay? So that's a good graphical example, I believe,
I think so.
of what that is and how you articulate that analytically. And now we are to these class notes of cumulative review, and I'll let you work on these, and it'll be fine. So we have that. So anyway, that's going to be what I have for, unless you want me to work on the first one? You okay on this? I'll just do this one. Okay, what we have is g of x is equal to, we have negative 3/5 x to the negative 5th minus 4 sine x. And so now, that's supposed to be an x. And so now we have g prime of x is equal to, I have negative 5 over 5, and negative 5 over 5 is negative 1, so I'm going to have 3x, and then we subtract 1, right, to the negative 6th, and what's going to be our derivative of 4 sine x? Negative 4 cosine x. And so, just to summarize here, g prime of x is equal to 3 over x to the 6th minus 4 cosine x. And that's number 1, okay? So I want you to go ahead and continue to work on the cumulative review.